So now we're going to introduce a couple of the other formulas on your reference sheets, specifically the ones labeled as the sum and difference, which you can find on the bottom of the front of the reference sheet I gave you guys. These are going to be very similar to what we've been doing before, where you're going to look for one of the applications of them and then just substitute in the expressions you see on the other side of the equal sign. But you're not going to be relying as much on proving them and showing step by step, showing out your work. This will be a little bit more computation based. So the idea here is to recognize that on our unit circle, we only filled out certain specific angle measurements like 0, 30, 45, 60, 90, etc. And there are lots of gaps in between that we can't do very easily without a calculator. Well, now with our reference sheet and the use of these sum and difference formulas, we're going to find there are ways to use the angles we're already comfortable with, like 60 and 45 degrees. And since we can subtract 60 minus 45 to get 15, there's actually a formula that will let us evaluate cosine of 15 degrees using these other two angle measurements instead. So that way we can still do some of them like 15 degrees and 75 degrees without needing a calculator. So these are the formulas that you'll be using for reference. And I should also point out that you usually have a choice on these. It's not set that you need to use 45 plus 30 to equal 75. You could also do something like 135 minus 60 to get 75. So usually there's a choice on whether you're picking two angles to add or picking two angles to subtract. It's just a matter of finding two numbers that either add or subtract to the number that you are looking for. Do be careful about the sign specified here. If you are using cosine of one angle plus another angle, then in your formula, that's saying you're going to have a subtraction sign in between. And then vice versa. If you are picking two angles where the difference is the desired angle, then in the formula you would use a plus. For the sine one, it's plus goes to plus, minus goes to minus, but for cosine it's flipped. And we'll do more of the tangent examples tomorrow, but you can see them there. So we already looked briefly at this example on an earlier slide. We haven't worked it all the way out yet, so we're going to do that now. But again, I want to point out that 15 degrees, we could find that by doing 60 minus 45, or we could do 45 minus 30. Either way, I have some choices on how I can arrive at this 15-degree angle. So neither one of them is incorrect. It's just going to change the computations a little bit, but it'll come out to the same answer in the end. Now on the earlier slide, I showed cosine of 60 minus 45, so that's going to be the version that we will use. So first step, find two angles on your unit circle that either add or subtract to the specified angle. Then we need to look at our formula, and on the reference sheet, we're doing a cosine minus formula. So in this case, I need to make sure that when I'm writing the other side that I am using a plus sign, and it's going to be cosine of the first number times cosine of the second number plus sine of the first number times sine of the second number. So those two numbers we picked, the 60 and 45, those will be the x and the y in these two spots. So I'm going to have cosine of 60 times cosine of 45, and then the sign flips when you're doing the cosine sum and difference formulas, so it's going to be a plus, and then sine of 60, sine of 45. So if we evaluate this, it's going to be the same answer as putting cosine of 15 degrees into the calculator. And the advantage here is that now I can do this if I don't have access to a calculator to evaluate this answer, because we know how to evaluate 60 and 45 degrees for both sines and cosines. So for cosine of 60 degrees, remember you're looking at the x-coordinate, so you would have 1/2. And for the x-coordinate at 45 degrees, you would have square root of 2 over 2. If you don't know these yet, just make sure you have your unit circle handy for reference. For the 60-degree angle, the y-coordinate is square root of 3 over 2. And sine of 45 is square root of 2 over 2. Now I do still need to simplify this sum. Don't just stop once you perform those substitutions. When you multiply fractions, remember you go straight across. So this would be square root of 2 over 4 plus, and then since both of those numbers are inside the radical, you can multiply them together, and that would be square root of 6 over 4. And And then since we have a common denominator, we can go ahead and write this as square root of 2 plus square root of 6 over 4. Now, I should point out that if you tested your answer into the calculator with this, it's going to show up in a different form. They are mathematically equivalent, but that's one reason you can't just use your calculator to get these answers, because it's not going to give you the answer in this form. It's going to give you some kind of a weird decimal or change the radicals into another form. So do make sure you actually know how to do this without using a calculator, only the unit circle for reference. Now, it is a bit trickier when you're doing these with radicals, but the same concepts apply. So we're still going to be finding two angles that either add or subtract to equal 5 pi over 12, but it's harder because you're going to have to think about common denominators and what would come out to this value. A hint I would give you for these is to take the radian measurements we have on the unit circle and then try to rewrite them using the denominator that they have specified. So for example, one of the angles I'm going to use on this one is 2 pi over 3, but it would be easier for me to recognize that I need that if I rewrote 2 pi over 3 as 8 pi over 12. So it's kind of like I'm unreducing the fraction. I'm trying to get it down to have the same common denominator. So I multiplied top and bottom by 4 of 2 pi over 3. And then the other one I'm going to use in this case is pi over 4. But if I got a common denominator on that, I'm multiplying top and bottom by 3. So I'd have 3 pi over 12. So these two fractions, I can either add or subtract in this case to get 5 pi over 12. So that's my 2 pi over 3 angle and my pi over 4 angle. So everything else from there is going to be very similar setup-wise. I'm going to have cosine of 8 pi over 12, or probably easier for you to think of it as 2 pi over 3 once you get to this point, once you've found the ones you want to use, times cosine of pi over 4, which is the other angle we used here. And then since I was subtracting the two angles in my formula, that's going to be a plus. So then it's going to be plus sine of 2 pi over 3 and pi over 4. So once you get that set up, it's just a matter of you computing these. Again, have your reference sheet, your unit circle handy for this. So cosine of 2 pi over 3, looking at the x-coordinates, is -1/2. And for pi over 4, your answer is square root of 2 over 2. This is where it becomes very handy to have the unit circle memorized, because then you can go through this quickly. The y-coordinate at 2 pi over 3 is square root of 3 over 2. And for pi over 4 is square root of 2 over 2. I'm still going to simplify this a little bit, so this would be negative square root of 2 over 4 plus square root of 6 over 4. And rather than have like a negative plus something, I usually flip those around and write it as a subtraction problem. So square root of 6 minus square root of 2 all over 4 would be the answer in this case. For our last example, I'm just going to show you how to work backwards a little bit on this. So what you want to look at is what kind of a relationship they have between the sines and the cosines. Notice when we were doing the last ones, it was cosine, cosine, sine, sine, but here we have them mixed up. We have a sine and a cosine and a cosine and a sine. So look back at the formulas. You can see that the one that mixes the sine and cosine values is the sine sum and difference formula. So I know I'm going to be doing sine of something, and then the other thing that's important to notice for sine is that if they use the plus sign between the expanded version, then it should be a plus sign for the two angles. It does not flip like the cosine one does. So I need to identify what the two angles are, x and y, and then we need to figure out if it should be a plus or a minus, and then we're just going to write one trig function using those combined. So since they use the plus, I'm going to be using a plus. And the two angles they have are 22 and 13 degrees. So I would have 22 plus 13, and like we said, since this one mixes the functions, it's the sine sum and difference instead of the cosine one. Now you could still combine these two angles, of course, because 22 plus 13 is going to equal 35 degrees. So now we have a single angle, 35 degrees, with sine attached to it. That way, if you had the longer version come up and you do have access to a calculator, it'd be a lot easier and it would save you a lot of time if you were to just recognize that you could hit sine of 35 degrees and get the same answer. So that's all for the notes. Thank you.